Hello, assalamu alaikum. This is Tosif Hussain, and I'm gonna explain finite automata. The job is finite, or the job of a finite automata is accept and reject the input depending on the pattern defined by finite automata. It is very simplest and model of a computation. It has very limited memory. We can define the finite automata. We can define in two sectors. One is DFA and one is NFA. DFA is deterministic finite automata and NFA is non-deterministic finite automata. DFA uses included protocol analysis, parsing, video game character behavior, security analysis, CPU control units, natural language processing, and speech recognition, and etc. So now we can see a picture of DFA here. What DFA is like, the the DFA should have a set. There should have Q. Q has its own meaning, which is set of all the state. Mu is here inputs. Q naught is the starting state and or the initial state. F is set of final states, and D is the function from it's called function actually. Tau tau is called function. So here the round and with the arrow, it is called the initial state, and it is changing the state with taking the input 1 to B, and B is changing the state taking input 1 to A. Then A is changing the state is taking input 0 to C. That's how this procedure works, and this is the state is final state. All over the strings we will have in DFA, we will accept only those which is ending with the final state. It means if any input of strings ends with this state, then the string will be accepted. So that's about it from my side. The next part of this video will be explained by my friend Arif.
Thank you, Tosif Ahmed, for passing the floor to me. And Assalamu alaikum, my name is Mohammad Arif. In our project, I have done non-deterministic finite automation. And let's look at the screen now what I have done so far. Thank you so much. Deterministic finite automation, and I am Mohammad Arif and I will discuss about NFA, what I have done in our project. So first of all, we need to know what is NFA. A non-deterministic finite state automata is a language recognizing system similar to ADFA. It supports a level of non-determinism. At some points in time, it is possible for the machine to take on many next states. Non-determinism makes it easier to express certain kinds of languages. And NFA acceptance. When an NFA receives an input symbol A, it can make a transition to 0, 1, 2, or even more states. Each state can have multiple edges labeled with the same symbol. An NFA accepts a string W if there exists a path labeled W from the initial state to one of the final states. In fact, because of the non-determinism, there may be many states labeled with W string. And here is a example. For that, the language of the following, as you can see, the language of the following NFA consists of all string over 0 and 1, whose start symbol from the right is 0, as you can see in the picture. Q0, Q1, Q2, and Q3. And Q0 has multiple transitions, 0 and Q3 has no transitions on both 0 and 1. And let's go to the next page now. This is the formal definition of an NFA. And NDFA can be represented by a 5 tuple, where you can see finite set of state. It is a finite set of symbol called alphabets, and it is transitions function where you can see this one. So let's get to the next point. Differences between N, ND, NFA and DFA. DFA, the transition from a state is to single particular next state for each input symbol. Hence, it is called deterministic. And for non-deterministic, the transition from a state can be to multiple next states for each symbol, each input symbol. Hence, it is called non-deterministic. And for DFA, empty string transitions aren't seen in DFA, and in NDFA, it permits empty string transitions. And for DFA, backtracking is allowed, and for NDFA, it's not always possible. For DFA, requires more space, and for non-deterministic, it requires less space. And for deterministic, a string is accepted by a DFA if it is transits to a final state. For NDFA, a string is accepted by it if at least one of all possible transitions in a final state. Thank you so much, Tosif Ahmed, for your hard work and for your good cooperation in our project. And thank you so much for your patience.